Hello, this video is a review of rational functions. You are welcome to watch this video while doing your review questions for the Chapter 7 test. Those questions are found in Big Ideas Math. Our first question says the variables x and y vary inversely. That word inversely is a big clue for this problem. Use the given values to write an equation relating x and y, then find y when x is 3. So when variables vary inversely, that means that the equation that you're going to write relates y with x in the form of a fraction. So y equals some number over x, okay? The way that you find that number is by multiplying x times y, okay? So if we take these two values here, x is 3/4 and y is 28. We can find our variation constant, that's the number on the top of our fraction, by simply multiplying 3/4 times 28. And you'll notice when you do this, if you turn them both into fractions, that 4 cancels into 28 7 times. And then you can just multiply straight across the numerators and denominators. Right? So 3 times 7 is 21, and 1 times 1 is 1. So then your equation is going to be y equals 21 over x. And then to find the value of y when x is 3, you simply replace the x part of your equation with 3. So y is going to be 21 over 3. I will let you finish solving that problem. The second problem, modeling with mathematics. When you stand on snow, the average pressure P in pounds per square inch that you exert on the snow varies inversely with the total area A in square inches of the soles of your footwear. Suppose the pressure is 0.43 pounds per square inch when you wear the snowshoes shown, right? So we're looking specifically at these snowshoes where A, right, the square inches of the soles of the snowshoes is 360 square inches. Write an equation that gives P as a function of A, and then find the pressure when you wear the boots shown, okay? So again, we have this word varies inversely, right? So that means that when we're relating P to A, we have P equals some variation constant over A. And the way that we find that variation constant is by multiplying P times A. Okay, so you're going to take this 360 and this 0.43 and multiply those together. So 0.43 times 360. You'll find that the variation constant is going to be 154.8. Okay, you use this value, this variation constant, to write your equation. And then you take the variation constant and divide that by 60. So 154.8, divide that by 60 in order to find the pressure in pounds per square inch when you are wearing the boots instead. Okay, I will let you finish that problem. Number 3, we're analyzing relationships in these graphs. We want to match the function with its graph. Okay, there are 4 graphs here, and I notice that the differences between the graphs are we have 2 graphs where the vertical asymptote has been moved right 3 units. This one has also been moved right 3 units. And then we have 2 graphs where the vertical asymptote has been moved left 3 units. And this one has also been moved left 3 units. Okay. And then additionally, on top of that, we have 2 graphs where the horizontal asymptote has been moved up 1 unit. This one has been moved up 1 unit. This vertical asymptote down here has been moved down 1 unit, and this vertical asymptote has been moved down 1 unit. So we need to look at our function, at the numbers in our function. We have in the denominator of our function x plus 3, and that plus 3 does the opposite of what you think it is, because x plus 3 cannot equal 0. It's a denominator. We're not allowed to divide by 0. When we subtract 3 from each side, we find that x cannot equal negative 3, which means that we actually want to move our vertical asymptote to the left 3 units. Okay, and then finally this minus 1 is going to take and move our horizontal asymptote down 1 unit. So I will let you match those together. This next one, we want to identify the graph of x plus 6 over 4x minus 8, and then state the domain and range. Okay, I noticed that right here, my denominator 4x minus 8 cannot equal 0. So if I add 8 to both sides and then divide by 4 on both sides, I find that x cannot equal 2. Okay, the graphs that show a vertical asymptote at 2 are this graph and this graph. Okay, and then the difference that I noticed between these two graphs are that this graph is aligned in the positive quadrants, right? We have positive and positive, whereas this graph is aligned in the negative quadrants. And if I look at the leading coefficient of my functions right here, 1 over 4, right? This is a positive. So I'm going to select this graph, okay? And that's going to mean that the domain, the numbers that I can put into my equation, are going to be all real numbers except 2. And the range of what I'm going to get out of my function is going to be all real numbers except, I'm going to go back over here to 1 over 4, so it's going to be all real numbers except 1 over 4, or 0.25. Number 5, we have using tools. This is another modeling problem. We have lowercase t represents the time it takes for sound to travel at 1 kilometer. That can be modeled by this function, t equals 1,000 over 0.6. Notice there's a capital T here, plus 331. Capital T is going to represent the air temperature. So there is a difference between a lowercase and a capital. You are 1 kilometer away from a lightning strike, and you hear the thunder 2.9 seconds later. Use a graphing calculator to approximate the air temperature. Round your answer to the nearest whole number. So what you actually want to do is you want to use a graphing calculator. So go to desmos.com and you're going to type in, but you're going to replace t with y and this t with x. Okay, so you're going to find that y is now the time and x is now the temperature. Okay, what you're going to do is you're going to graph this function in Desmos, and then you're also going to graph this 2.9 seconds. That's a time. So you're going to graph y equals 2.9, and you're going to see where those two functions cross. Okay, you'll notice when you graph them, you have one function that is your rational function, right, which relates the time in seconds to the air temperature. And then you have a second one that is just this y equals 2.9, and you're going to see where they cross, right? You're going to look for that x value, and that is going to be the temperature of the air when this lightning strike happens, okay? And then when you find the average rate of change in the time it takes sound to travel 1 kilometer as the air temperature increases from 0 degrees Celsius to 100 degrees Celsius, again, you're going to go to your graph and you're going to look for Celsius is a degree, so that's your temperature. When x is 0, you're going to find the point on your graph. And when x is 100, you're going to find the point on your graph. Okay, you're going to get 2 points on your graph, x, y. So you're going to have x is 0, find y, x is 100, find y, and you're going to look for the slope, which is rise over run, which is also the change in y over the change in x. Okay, I'm going to let you pause the video and do that on your own. Our next problem, again, we have another word problem which relates rational functions to the real world. Your school purchases a math software program. The program has an initial cost of $500 just to buy the program, plus $20 for each student that uses the program. Okay, so we have $500 up front and $20 for each student that uses the program. So the total cost of using this program is going to be your $500 that you pay up front, or that the school pays up front, plus $20 per student. I need something that represents the number of students. I'm going to use X. Okay, if I want to take this and make an equation that relates it to the average cost per student, the average cost per student is going to be this 500 plus 20x, the total cost, divided by the total number of students. So this entire thing divided by the total number of students. Now we want the average cost to fall to only $30 per student. So the average cost is going to be 30 equals 500 plus 20x all over x. Okay, in order to solve this equation, you would simply multiply both sides of your equation by x, which is going to cancel the denominator. Okay, and then you'll see that you have 30x equals 500 plus 20x, and that equation you can solve on your own. Okay, the answer to that equation, the value that you get for x equals how many students, is what the first part of your problem is asking for. Okay, the second part of your problem, what happens to the average cost as more students use the program? Well, in order to find that, we are basically taking this $500 and spreading it as thin as possible across lots and lots and lots of students. Let's say we have 1 million students. If we take 500 and divide it by 1 million, then really the only thing that's affecting the cost per student is going to be this 20x, right? So that means that the average cost is going to decrease to be only about $20 per student. Okay, our next problem, we have simplify the expression if possible. If the expression is already in simplified form, enter the given expression. So the first thing that we want to do is factor. Always factor when you're simplifying. Okay, so we have 7x cubed minus x squared all over 2x cubed. I'm going to factor out this x squared from each term in the numerator. So that's going to be x squared times 7x minus 1. And that's going to be all over 2x cubed. Okay, so now I notice that this x squared can reduce into this x cubed, right? If I reduce x squared into x cubed, I'm just left with x. So that this is going to be reduced to just 7x minus 1 over 2x. So that is simplified. The next problem, simplify the expression if possible. If the expression is already in simplified form, enter the given expression. Okay, so again, the first thing that I want to do is factor. Always factor first. Okay, that way you can see if things will cancel out. Okay, so to factor this numerator, I'm looking for numbers that multiply to 36. So 36 could equal 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. And now I'm going to seek in this list of factors of 36, I'm going to look at which pair will add to 13. Well, 1 plus 36 is 37. The only pair that adds to 13 is going to be this 4 times 9. So the numerator of this fraction is going to factor into x plus 4 times x plus 9. Okay, now let's factor the denominator. So in the denominator, we're looking for numbers that multiply to 10. That's the last number there, right? So 10 could equal 1 times 10 or 2 times 5. And then I want in this list, I want numbers that will add to make -7. Since this needs to be a negative, that means that both of these numbers need to be a negative so that when I multiply negative times negative, we get positive. So we could have -1 times -10 is positive 10. See how that works? We could have -2 times -5 is positive 10. Now, if I want them to add to equal -7, I'm going to choose the -2 and the -5. So the denominator is going to equal x minus 2 times x minus 5. Okay, and if you look at this, I don't have, within my parentheses, I don't have another x plus 4 to cancel. I don't have another x plus 9 to cancel. I don't have an x minus 2 to cancel, and I don't have an x minus 5 to cancel. So in the directions where it says enter the given expression, literally, I need to take this and type it exactly as it is into here. Okay, make sure when you're doing that this, for example, the plus is down. It's not still up in the exponent. Okay, our next problem, we have find the product, write your answer as a fraction. Okay, and I notice that I have two places to enter x cannot equals a value and x cannot equals a value. That gives me a hint that I have two factors that will cancel out. Okay, so I'm going to factor as much as I possibly can in each of these fractions. So x squared minus 4x, I can cancel out I can factor out an x, and that's going to leave me with x minus 4 over x minus 1. Okay, in this numerator up here, I've got x squared plus 3x minus 4. Again, I'm looking for numbers that multiply to -4 and add to positive 3. So that's going to be x plus 4 times x minus 1. Okay, and then in the denominator, I have 2 times x. Okay, so now I can factor out identical terms. I can factor out this x minus 1, right? Since I'm canceling that out, x minus 1 cannot equal 0, which means that x cannot equal 1 when I add 1 to both sides. That's going to be one of my restrictions. Okay, likewise, I can cancel out this x in the numerator and this x in the denominator. When I cancel those out, I have to consider that as a restriction. X cannot equal 0, so my other restriction is that x cannot equal 0. Okay, and finally, I just need to rewrite and multiply everything that is remaining. So I've got x minus 4 remaining, x plus 4 is remaining, and 2 in the denominator is still remaining. So my final solution is going to be x minus 4 times x plus 4 all over 2. And that's what's going to go here. Okay, next we want to find the sum. Okay, we want to find the sum. Sum means add. Now this problem is actually pretty cool because I noticed that the denominators are exactly identical. So really all I need to do is add the numerators together and put those over the common denominator, right? 3x squared plus 6x over that common denominator of x minus 8, and you're good to go. Okay, our next problem, again, we want to find the sum. In order to find the sum, we need to factor so that we can get common denominators. Okay, so I'm going to take this first fraction, 12 over x squared plus 5x minus 24, and factor the denominator into x plus 8 times x minus 3. Okay, because 8 times negative 3 multiplies to negative 24, and 8 minus 3 combines to positive 5. Okay, and then that's going to be added to 3 over x minus 3. Okay, so now I need to make common denominators, and this denominator has an x plus 8 multiplied with an x minus 3. The other denominator only has the x minus 3. So I need to multiply the numerator and denominator over here by what it's missing, x plus 8 times x plus 8. Okay, so now I'm going to go ahead and distribute 3 to the x and also to the 8. Combine the numerators and put that over its common denominator. Okay, so I'm going to have 12 from the first fraction plus, when I distribute the 3 times x is 3x, 3 times 8 is 24. And then in the denominator, I just need to list the common denominator once. So x plus 3, or x plus 8 times x minus 3. Let's go ahead and combine like terms in the numerator. So we have 3x plus 12 plus 24 combines to a 36. That's going to be over x plus 8 times x minus 3. And then we want to factor in this numerator. They both are divisible by 3, so I'm going to factor out a 3 and call this 3 times the quantity of x plus 12 over x plus 8 times x minus 3. Now, the last thing that I check is, can I cancel out x plus 12 with either of these? No, they're not identical. Can I cancel out a 3 with either of these? No, they're not identical. So this is the final solution. All right, our next problem, we have 4 over 2x equals 5 over x plus 6, and we need to solve by cross multiplying. So when you cross multiply, it literally means take the numerator across and multiply the denominator. Remember to distribute. So 4 times x is 4x, and 4 times 6 is 24. Okay, take the bottom, take the denominator, and go across and multiply with the other numerator. So 2x times 5 is going to equal 10x. And now this equation is much simpler. When you find your value of x, make sure that when you plug it into your equation right here and right here, make sure that it doesn't cause either denominator to equal a 0. I'm going to let you finish that problem on your own. Our next problem, we have solve 8 over 3x minus 2 equals 2 over x minus 1. We need to solve that by cross multiplying. And when we cross multiply, we have 8 times x minus 1, right? Remember to distribute. So that's going to be 8 times x is 8x. 8 times minus 1 is minus 8 equals, and then cross multiply, 2 times, remember to distribute, so 2 times 3x gives you 6x, minus 2 times 2 gives you 4, okay? And again, this is a much simpler equation. It's a linear equation. You're going to get one solution. Just make sure that the one solution that you get, x equals whatever that solution is, make sure that it doesn't cause x minus 1 to equal 0 and make sure that it doesn't cause 3x minus 2 to equal 0. Okay, number 14, we want to solve this equation, again, by cross-multiplying. So we're going to cross-multiply -1 with x squared minus 27. So when I distribute that, we get negative x squared, right? -1 times x squared is negative x squared. And then -1 times minus 27 is going to be plus 27 equals, when you cross multiply this, you have a binomial times a binomial. Okay, I'm going to write that out as it is. So we have x minus 3 times x minus 4. Okay, you can FOIL that. You can use a box. I'm going to go ahead and use a box just to remind you of what that would look like. X minus 3 times x minus 4. X times x is going to be x squared. X times minus 4 is going to be minus 4x. Minus 3 times x is going to be minus 3x. And last, minus 3 times minus 3 is going to be plus 12. And when you combine like terms, let's see what that looks like. We have negative x squared plus 27 equals, we have x squared. Combine like terms, minus 3x and minus 4x is minus 7x. And then plus 12. Okay, and then since this is a quadratic equation, right, x squared and x squared, but this x squared is negative, the x squareds don't cancel out. So what you actually need to do is add x squared to move it to the other side, add x squared, and then you also need to subtract 27. Okay, and when you do that, it causes the left side of your equation to just equal 0. 0 equals 2x squared minus 7x minus 15. Okay, so now we are looking for 2 and negative 15. When we multiply those together, we get negative 30. So we're looking for numbers that multiply to equal negative 30. So we could have 2 times negative 15. We could have 1 times negative 30. We could have 3 times negative 10. 4 does not go into 30 evenly, so let's skip to 5. We could have 5 times negative 6. Okay, and when we look at that, now we want to identify numbers that add up to negative 7. Well, that's going to be 3 and negative 10. When we add those, we get negative 7. So that tells me how I'm going to fill my box. Okay, so I'm going to draw another box. And this box is going to be filled with what I'm trying to factor. So 2x squared. Okay, I have a 3, so that's going to be 3x. I have a negative 10, so that's going to be negative 10x. And then I have minus 15, so negative 15. And now I want to factor out what I can, and this is going to help me factor this into two binomials, right? We're going to get 0 equals something times something. Okay, so I notice that 2x squared and 3x, they both have an x in common. Negative 10x and negative 15, they both have a negative 5 in common. Okay, then I noticed that 2x squared and negative 10x both have a 2x in common. 3x and negative 15, they both have a 3 in common. So this x minus 5 and this 2x plus 3, that's how I'm going to factor my trinomial into two binomials, right? X minus 5 and 2x minus 3. Okay, now the way that you solve these is you apply the zero product property. So you have x minus 5 set equal to 0. And you have 2x minus 3 set equal to 0, right? When you solve that, subtract 3 from each side, divide each side by 2, x equals 1.5. Oops, that's a plus 3, so this is a negative, and this is also a negative. Okay, check each of these answers. When you put 5, 5 minus 3 is not 0. When you put a 5 here, 5 squared is 25. 25 minus 27 is not 0. So this answer totally works. When you plug in negative 1.5, negative 1.5 minus 3 is not 0. Negative 1.5, square it, subtract 27, that is not 0. So this x equals negative 1.5 is also a totally valid answer. All right, and next we have this equation. We have, so far this baseball season, you have hit 12 hits out of 60 times at bat. Solve the equation. 0 equals 0.360 equals 12 plus x over 60 plus x to find the number of consecutive hits you need to raise your batting average. Okay, so where they got the 0.36 from is we want to raise the batting average to a 0.36. Okay, where they got the x from, x is the number of additional consecutive hits that you need in order to actually raise your batting average. Because right now, your batting average, if you do 12 divided by 60, 12 over 60, that's only a 0.200, right? You're only batting a 200 right now. We want to raise your batting average to a 360. Okay, so in order to solve that, we're going to go ahead and multiply both sides of the equation by this 60 plus x. So 0.36 times 60 plus x equals 12 plus x. Okay, when you multiply those together, you're going to distribute this 0.36 times 60, and then you're going to distribute this 0.36 times x. Okay, and then you'll notice that this is a linear equation. When you solve this linear equation, you do just like you do any other linear equations. Get the x's on one side, get the constant numbers without an x on the other side, and then you can find out how many hits you have. Okay, I'm going to let you complete that problem on your own. And this actually comes to the end of our little tutorial video. You notice that I didn't really give you all of the answers because I want you to go ahead and have time to think on your own and increase your understanding. Please let me know if you have any questions. Thank you for watching.